All right, everybody. Hello, hello, hello. Welcome to another episode 112 of TGI Kubernetes. I'm your host, Joe Beda. I'm a principal engineer at VMware. And for those not in the know, TGI Kubernetes is a weekly-ish thing where me or one of the other folks on our team gets together and does a deep dive into something Kubernetes. It could be a new project. It could be a piece of the technology. And we just spend some time really going in depth and exploring this stuff. A lot of hands-on keyboard. For me, oftentimes I pick things that I'm not expert in, so we get to actually learn together. And so that's what we're going to be doing today around admission controllers. But I'd like to start off, first of all, by saying hello to everybody. First of all, yes, I do have a green screen now, and I'm not afraid to use it. This is the new world with Zoom and everything else going on. I decided to get fancy, and I can change my background and stuff. This is not too distracting, hopefully, but been having a lot of fun with that. So hello to everybody. I'm just going to read through the comments here a little bit. Mazuffer, nice to see you. Maddie, good to see you. Rory from Lochgoilhead. Hushang. Joy, Walid, good to see you. Robert from Dublin. Martin from the Netherlands. Tim, also in Dublin, California version. John, good to see you, John. Muckletio. Let's see, Joe from Atlanta. Shahar, awesome. Sharash, good to see y'all. Oh man, so more than I can go through. We have Ian, they're calling in from Minneapolis. Let's see, Steve, good to see you. I can't list everybody. Jan from Germany. Ram from Seattle, first time here live. Thank you for joining us. So good to see you all. The format of TGIK is I like to start off with, we pull together some interesting links of what's going on in the contributor community and around the larger community. George and Duffy oftentimes contribute to that. Go through that. Try not to spend too long doing that. And then we start doing a deep dive. The topic today is going to be admission controllers. And I'm actually going to be writing some code and deploying these to a cluster. Oh man, and I forgot to actually start my cluster. I got distracted by stuff. So we'll do that also. I'll show you how to bring up kind with a 1.18, and then we're going to install an admission controller to that thing, which actually should be good. It's going to be fun. So let's go ahead and get started here. What we have is, let me see here. Okay, let me switch to my screen and we can go ahead and get started. Oh, Argo CD 1.5 is out. Yes, I should have put that in there. Okay, so first of all, we crowdsource notes using this great tool called HackMD. It's you can actually join in hackmd.io notes, or tgik.io, sorry. So feel free to join in, and Spaceboy978, if you could actually put a link to an article on Argo CD there, that'd actually be great, because that was, I forgot to mention that. So go ahead and do that. And if you want to like put other notes in there or like time codes, I think that's great. I haven't done it for last week yet, but I generally take that stuff, like, when we start talking about stuff, I'll put that in the YouTube video so that folks can jump right to stuff. All right, so let's actually start digging into stuff. So the first one here is that there is a KEP about KEPs. So this stuff is kind of inside baseball in terms of how the Kubernetes community works. And so a little while ago, we started this thing called KEPs, Kubernetes Enhancement Proposals. And one of the exciting things that I didn't know this was going on, but we're actually sort of modernizing that proposal. We've learned from some stuff and getting better about this. And so this is how we try and make changes in Kubernetes, do it in a way where things are well documented. A lot of folks have a way to actually review it, and we can track these things over time. And so a lot of really good changes here in terms of how we're doing that process. So if you're involved in KEPs, worth taking a look at that. Good lessons to be learned from that. So I'm really excited to actually see this moving ahead and seeing folks fixing some of the bugs of that process. So very, very cool. So the next thing, and this one's really exciting for me, is when we publish stuff, releases from Kubernetes, traditionally, a lot of these things were really focused on only Googlers could do certain steps, right? And so like early on, like the container images were actually intermixed with some other stuff, and it had this Google container thing on it. And so we weren't, like when we started Kubernetes, we weren't super essentially strict about sort of thinking about what stuff was community driven and what stuff was Google driven. And so I opened this this issue. It's number 270 in the release repo back in 2017, saying like, we need to actually sort of get more a separation here so that community folks can actually do releases. And this is making some huge progress. And one of the big things that we're doing as part of that is moving the images to kates.gcr.io instead of gcr.io/Google containers. And so flipping this stuff around a little bit so that it's Kubernetes optimized and folks in the community can get more involved. And my understanding here is that the actual flip happened during a Zoom call on one of the meetings, which is actually really cool. So this is actually really good progress of sort of moving stuff out of a place where only Googlers can drive it to where the community can start driving this stuff. So I'm really excited about that. And then Stephen Augustus also pointed, he has a KEP here talking about issue triage, trying to get a handle on the number of issues we have in Kubernetes, what folks are looking at, and how stale they are. So if you're interested in that, feel free to take a look. Again, this is a little bit of inside baseball in terms of the way that we run stuff inside of the Kubernetes community. But I think, we're all learning, and it's, I know a lot of folks are looking to get involved and are interested in it. So there's some stuff that you can dig into. All right, so that's the sort of core Kubernetes stuff. As we look across the wider ecosystem, got some really interesting stuff going on here. So the first one, and I hadn't seen this until I saw it show up here, is that there's this new site called videos.cncf.io that actually pulls together all of the videos across all of the KubeCons and stuff that the CNCF has been publishing, and to really see that stuff in a much more searchable, categorized way, I think is really, really cool. And so it looks like they've included videos from the last couple of KubeCons. And it's, because I don't know if you've ever tried to find a video from a KubeCon on the CNCF YouTube channel. It's like there's just like way too much there. So it's really cool to actually see a better dashboard for finding this stuff. So I'm really excited about that. All right. And let's see. Oh, and then this one is actually really cool. This is a new tool called Kubi, which is a rethink about kube context and kubeNS and sort of the relationship with the global Kubernetes kube config thing. And I think, this is one of those things that has always bugged me a little bit, is that, when you look at your kube config, it has these three things. I don't know if you've ever dug into this, but it's you have a list of clusters, a list of users, which is sort of like credentials, and then a set of context, which is sort of how these things come together with namespaces. And from a sort of denormalized or a normalized data model, I think this makes a lot of sense. But the reality is that your kube config is really a database. And the commands for actually modifying those things are not super obvious. And so we've been sort of patching over that. And I think one of the things is, coming out of the community is the kube context and kubeNS, which make it easier to switch between contexts. Those things are definitely good. But I really like what's going on here, which is thinking about taking that one database that is the kube config and exploding that into a bunch of files that get sort of combined back together. I haven't had a chance to really dig into it, but it actually looks really cool, and it's something that I would love if we could actually, and I think maybe the cat's out of the bag and it's too late, but I would love to get to a point where we move away from the global kube config into something that is more decomposed like this. So maybe this is a good way to start exploring some of those ideas. So that's actually really cool. I'm gonna have to find some time and play with it. So this is exciting. So this is a blog post from the Linkerd folks about using Linkerd with Knative. And so when Knative came out, and I think if you rewind, I did a TGIK. It's moved a long ways since then. But Knative had a really hard dependency early on Istio. And one of the things that we're seeing is that the Knative folks have created more separation there in terms of the requirements that they need from the routing layer to be able to do the type of stuff. Oh, when I look away from the mic, my audio gets quieter. All right, so I'll try and keep the mic right here. Thanks for the reminder, Ian. So yeah, so yeah, and so now like we're seeing that we can have Knative work with Linkerd, work with a bunch of other stuff, and I'm really excited to see more sort of loose coupling between that stuff. Hi, Vivian from Munich. So yeah, so that is really exciting. And so here's something that actually goes into details around that. Really like to see, again, more loose coupling between Knative and the other parts of the ecosystem that it's depending upon. Let's see. So the other thing, so this is really cool. This is the Managed Kubernetes Inspection tool, which is, I love, all the tools where, we're essentially using Kubernetes and automation to look at configuration and drive essentially advice on how to run things in a conformant or secure or all these sort of different sort of linting tools that you can do on your environment. Most of those things don't have any knowledge of the underlying platform and stuff. So this is one of those that actually understands, like, okay, here's some of the pitfalls that are specific to GKE or EKS or AKS, that type of thing. And I think that's actually pretty cool to actually see these things go a little bit deeper there. So very, very cool stuff there. Check that out. All right, I'm gonna keep going. Alex Ellis, who is the person behind, among other things, OpenFAS, has this article that goes into a little bit of the history around Raspberry Pi clusters and Kubernetes and how these things work together. And I think it's really, really fascinating to see how folks, because you can boot up a Raspberry Pi cluster for under $100 you can get going with this stuff. And so it's really cool to see how people are playing around with Kubernetes on top of this. He goes through a lot of the history here. Also a shout out to Lucas, whose Twitter handle is Kubernetes on ARM, to actually sort of doing a lot of the work along the way to actually get this stuff up and running. So if you want to play around with Kubernetes on Raspberry Pis, looks like there's a lot of really good info and history going on here. All right, keep moving. Okay, so Google announced this project called KEPT, KPT. I'm still wrapping my head around what's going on here. It's sort of a meta tool for managing Kubernetes, packaging tools, with the idea that there's ways to download stuff from a Git repo, apply changes to that, update it again, and then processing, so essentially workflow about how you want to actually manage checking in, checking out, modifying, dealing with sort of different versions of your config. So it's kind of a little bit of a meta thing. All right, we should be back. Can you all hear me? So yeah, I think something broke on the YouTube side. I had to actually switch to the backup stream destination for YouTube. So I apologize for that, folks. Back up. Sorry about that. Yeah, a lot of folks dropped. Hopefully they'll join back in. All right, so we're talking about KEPT. The interesting thing that I think with KEPT is that it's sort of this meta thing where you can essentially tell it to modify some file in some way, and it's just a generic way to essentially patch YAML and some way of patching YAML. So if you have a YAML file, Kept knows how to actually manage workflow to Git and then patch that along with some, doing other types of transformations. So, oh wait, Ian says still not working. Okay, refresh to get it back. Sorry about that. All right. Okay, so yeah, I think there was a hiccup on the YouTube side. I have had OBS crashing on me, but let's hope that we don't have this happen again. Okay, so yeah, so the other thing that worries me about Kept, and it's an interesting thing where I'm on a personal level, as Google introduces these things, based on the relationship and the history around Istio and Knative and the level of control that they've been holding on, I think it's going to be interesting to see if Google can establish these things as wide usage across their community. I think seeing things like, pushing, installing this through gCloud, I mean, that's good, but also it really shows that there's a super tight coupling between Google and this stuff, and it's going to be interesting to see if they can build real community, real usage around this, or whether it's something that's going to be Google only. I think that it's clear that Google's recalibrating their relationship to open source projects, and I think this is one of the first things that they've launched after that. Now, what's interesting is that this is the week when KubeCon was supposed to have happened in Amsterdam, and so maybe they were probably planning on launching and talking about this there, and just decided to actually drive it anyways. All right, so let's see. Here we are. Let's see, other stuff that got launched. Cortex 1.0 is out. So Cortex is a CNCF sandbox project that does essentially scale out of Prometheus. Highly available multi-tenant stuff. That'd be a fun project. I'd love to actually dig into that at some point. Let's see. And then here's the link to Argo CD 1.5. Really cool to see that coming out also. Let's see. Better performance, integration with Helm 3, local accounts and stuff, bunch of bug fixes. So some really cool stuff coming out of that. All right. Okay, yeah, KubeCon Amsterdam. So August 13th to 16th, it got delayed. But it's sad that we're not there right now for sure. All right, two more things, and then we're going to actually dig into the admission controllers. The Valero team, and so for those that are not familiar, Valero is a backup and recovery project for capturing the state of your cluster, looking for feedback from the community. And so if you use Valero or if you're interested, please take a look at the survey that we have posted here. Would be really great to get your feedback there. And then one last thing, again, Stephen put this in here. We now have a contributor strategy SIG in the CNCF. And so the CNCF is a the whole goal of the CNCF is to help projects be successful. And so this is essentially, sharing tools, techniques, strategies on how to actually engage with your contributors as a way to sort of like up level all the projects across the CNCF. So it's great to actually see that happening too. All right. So that is where we're at with notes. I went a little bit longer, I think, because we lost the stream. So hopefully we won't have that happen again. Now I'm going to actually dig into admission controllers. Oh, the first thing I'm going to do here, and I forgot to do this, is I want to make sure that I have a cluster up and ready. I usually do this before we start, but let's do Docker. I think I have my cluster from last week. So we can do delete cluster. We'll do that, and then we'll actually do another one here. So yeah, these were in the HackMD from last week. And so we'll get that actually going in the background there. All right, cool. So let's talk about admission controllers. So the first thing is there's a great blog post that was posted almost a year ago now that goes into the detail here. And the really interesting thing here is, I think, which is great is this this diagram here, which is kind of a sort of life of a request into the API server. So so first of all, let me just quick review. I have this blog post that I wrote a long time ago, where I have a diagram also. So this is sort of like roughly, what a Kubernetes cluster looks like. And the interesting thing here is that we have the API server, and it really is the meet me point for everything that happens in Kubernetes. Everything comes in through the API server, whether it be from end users or whether it be from other parts of the cluster or the control plane. And so what happens is that the API server ends up being a critical sort of policy control point for everything in the system. Behind the scenes, stuff gets stored in etcd, but the only one who really should be accessing etcd directly is the API server. And we've actually seen folks do experimental things where they have replace etcd with other types of databases in the background there. So this is sort of like, my overly simplistic diagram of Kubernetes. But then if we actually dig in, and so this is sort of zooming into the API server itself has sort of a set of stages that happen as a new request comes in. And so you'll see things like, authentication and authorization. You'll see, and then we have a bunch of stuff that we call admission controllers. And so admission controllers, there's two types. We have mutating admission controllers and validating admission controllers. And so these things essentially are, things that are sort of pluggable parts of this pipeline, where the mutating ones can take the request from, whoever's calling it from the API, do whatever changes they need to do, and then pass it on to the next admission controller. And then it goes through object schema validation, making sure that everything looks good. And then there's a set of validating admission controllers. And these things essentially say yes or no whether they want to allow this. So this ends up being a policy breakpoint. And if they disallow it, they can return errors for why they disallowed it in a way that the end user from kube controller from the API actually gets some feedback on what's going on there. And then this stuff gets persisted to etcd along the way. So this is the overall flow of a sort of life of an API request into the API server. Somewhere in here, and I'm honestly not sure where, is also audit hooks, right? And so the admission controllers, I believe, only come into play when you're trying to update or change a resource in Kubernetes, whereas the so these phases won't come into play when you're just getting a resource. Whereas the audit logs, which I believe are configured currently, there's an alpha feature to do it from within the cluster, but right now can only be configured with changing flags to the API server. I believe those things happen for every request. But I'm honestly not sure if the audit logs actually happen before or after the admission controllers. That's something that I'd have to actually dig into. If somebody on the line here knows, I'd love to hear about that. So yeah, so what's interesting here is that there's a bunch of, like, when we first started doing Kubernetes, we built in a bunch of these admission controllers, and when I'll go to the documentation, you can see all the built-in admission controllers. And then we recognized that there was always going to be policy and things that folks wanted to do that were going to go beyond what we had built in. And so then one of the built-in admission controllers is what's called a webhook admission controller. And so this is a way to essentially configure an external call out from the API server. And so this is one way that you can take the Kubernetes control plane and extend it with new policy, new capabilities. And so, I did an episode a little while ago around OPA, which is the Open Policy Agent, and the primary way that it integrates with Kubernetes is via one of these admission controllers. And so this is the general idea of how this stuff works. And what I want to do today is write an admission controller, install it into a cluster, and then play with it and get a feel for sort of what's happening under the covers here. That's my plan. Let's see. So other stuff. So here's some good docs on the dynamic admission controllers. These are the webhook ones, but then there's also admission controllers in general. And here you can see, here's all the built-in ones, right? So what does each of these things do? And then there's also like you can change with flags. You can turn on some of the built-in ones and turn off some of the built-in ones. Yeah, and you can see that there's things that do certificate approval and signing. You know, like I'll give you, there's some security sensitive ones that have some performance trade-offs. And so this is essentially a tunable here. But so one of the things that we see here is that there's an admission controller for always pull images. And what this will do is that it will modify. So it's a mutating admission controller that will modify every new pod to force it to actually pull the image pull policy to always. And this is actually interesting from a security point of view, because if you have if you're sharing, multiple different people are sharing a cluster, and some of them have permission to run some images but not other images, and it happens to be cached on the node, if you say you want to use cache, then you actually may have information leakage from one run to another by just reusing your cached images versus actually pulling the latest and greatest one from your resource. And so these are some of the sort of policy decisions that you can make with a with an admission controller. Let's see. And so there's a bunch of these things, I believe, and you can all correct me if I'm wrong, that the mutating admission controllers happen based on alphabetical order, or at least based on, at least the webhook ones do, are based on alphabetical order. And they happen one at a time, because what if the output of one gets passed into the input of another? And then the validating ones actually happen in parallel. And then there's also, like, there's some interesting stuff that happened. Let me find it, because there's some notes in here. It's all sorts of cool policy stuff that you can play with here. Gosh, where's, I think it's somewhere in this doc. Oh, no, this is, in this one is best practices and warning, is that there's, that, you may find that your admission controller gets called multiple times for something, because you may have one mutating admission controller and then it'll actually go through and call another one. And so as you're registering the admission controller, there's ways to register to say, I want to see all updated versions. And so it sort of does a bunch of these things until it actually here, the failure policy and reinvocation policy, right? And then there's things like, because these things are webhooks, do you want to fail open? Do you want to fail closed? And so there's a lot of sort of performance and reliability stuff here, because if the endpoint for these admission controllers is not there, then do you want to let stuff through or do you not? And so this ends up, if you actually fail closed here, this ends up being an absolutely critical piece of your infrastructure. And if these admission controllers, if these, whatever servicing these webhooks go down, then your entire cluster crawls to a halt. All right. So, yeah. Okay. So, yeah, we're talking in the chat here, order, I believe, yeah, the webhook ones are based on alphabetical order. At least it's deterministic, right? All right. So the place that I'm going to start from, and this is interesting, is that inside the Kubernetes code base, there's a bunch of container images that are created for the Kubernetes end-to-end tests. And so these things are created and pushed every once in a while. And they're essentially sort of test fixtures that are used in the E2E tests. And then there's, one of these things is essentially a big sort of combined one that brings a bunch of these things. All right, am I sending again? What the heck? What the heck is going on here? I think YouTube's having problems. I'm going to blame YouTube. All right, where did I left off? So I took the stuff out of the end-to-end test. I extracted it. I made it so that we could build it separately. And I got to the point where I can build it, but I haven't actually dug in a lot there. And so this is what we're going to be using as a start. Okay, so you're all back. And so what we can see here is I took that stuff and I did some like Go mod stuff and client Go, and it actually wasn't that hard to get up and running. I had to change the package to main. And now essentially what I can do is I can do Go build, and this should actually go through and build something. And then I can run test admission, and it's going to give me an error. And the error here is actually because it's trying to load some TLS configuration. We can't actually go and do that. And so that's where we're at. So we essentially have a start. I can boot this up in VS Code, and we can see what we got going on here. And the way that this works is we have a main, and this pulls in a bunch of stuff. It's just a simple web server that has a serving certificate, and then has a bunch of sort of test endpoints for doing admission controllers. So that's actually cool. Yeah, so yeah, it could be that YouTube's having problems because too many people are streaming and we're all at home and all that. So that might be what's going on there. This is the first time I've had these issues. We've had problems with YouTube's in the past, with YouTube streaming in the past, but this is the first time I've seen this. All right, so we got this stuff up and running. And so the first thing that we want to do is I want to package this in a back. All right. Are we back? All right. All right. Phew. I'm sorry, folks. Oh, wow. You know, it looks like a ton of people dropped off. They're coming back now. I'll wait for folks to get back on. All right. So I switched back to the primary YouTube stream. Hopefully we won't see this happen again. This is rough. All right. All right. So where was I? Okay. So we have VS Code. We can build this thing. Now we're going to actually go through and figure out how to deploy this. And so two things we need to do is we need to build an image. And then, yeah, I think we lost most people, unfortunately. Oh, well, we'll still have the archive. You all will say you were here. All right, so yeah, so what we're going to do is we're going to build an image, and I'm using this with kind. We're going to get this stuff pushed to kind, and then we're going to go from there. And so one of the things that I wanted to play around with here is Co for Kubernetes, which is a way to build and deploy Go apps, which is kind of fun. And so let's see. So we can do. Believe I haven't tested this out yet, so this is we're gonna play around with this and actually see what we can make happen here. This is probably similar to the Minikube stuff. Yeah, let's see. So okay, so we can do kube control, blah blah blah, deploy. Okay, so we can do the co-docker repo to say local. And now we can do I think. Okay, so this will actually name the things that way. Okay, so now if I do what do I do? Publish. Oh, failed to publish, import path is not supported. Oh, why isn't it? All right. So Co and Go mod and stuff like that. I don't know. Do you all have, for this to work, you're gonna have to kind load Docker image from the kind node. Yeah, that's one of the things that I'm thinking about. So that's gonna be a little bit tricky. And this thing is actually giving me problems. We may, kind doesn't expose a Docker registry like Minikube does. All right, we could start a Minikube. Yeah, let's start a Minikube. brew update minikube, brew upgrade minikube to get the latest version going on there. Yeah, I want to actually get a better flow with co and kind. I think that'd be interesting. Yeah, the motion capture suit, that's not what I need. All right, so, oh, minikube not installed. What? Where is that stuff? Ah, geez. Okay. All right. Well, we're going to do this the hard way. We're going to do a Dockerfile to actually build this thing. Oh, are you all getting like super low resolution? Maybe try giving it a refresh and maybe it'll actually get... Yeah, because this is going to be hard to see. I can make things a little bit bigger. Yeah, okay. All right, so let's see. I'm getting distracted here. Okay, so let's go through and let's create a Docker file here. Touch Docker file. And, you know, oh, that's not what I wanted to do. Here, Docker file, and then like, you know, Golang Docker file example. I'm sorry that everything is so rough, folks. So this thing's really tiny. All right, so let's see. So we want to go through image variants. This is probably the easiest way to do it. And I was planning on using co, but I don't think I can use co with, like, it's giving me a hard time. Actually, let me see if I can actually figure out how to use co, because that'll be the easiest thing. I don't want to do the Dockerfile thing. Let's go through. So we have co uses blah, 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 overriding the base for particular imports. Including static assets. Why is co not working? So it's saying failed to publish images, import path is not supported. All right, so is it still blurry, folks? One of the goals is code to make containers invisible. Import path for your Go library. So the problem is that determining... Okay, so it only works, oh, when you're in Go path. Blah. Is there a way to actually override that? I'm going to have to ask Matt what's going on here. Yeah, I can't make this be... Okay, so here's what we're going to do. We're going to go through and export go path equals go. Oh, actually, no. I want to do this one. Make dir go. Make dir -p go source TGIK.io / do that. Move test admission to go source TGIK.io. cd go source TGIK.io. cd test admission. Let's actually close code. All right, so we're up and running now. Go publish dot. All right, that's working. Okay, so it's pulling a bunch of stuff down here. Yeah, so one of the nice things about Go modules is that you don't have to actually write code inside of your Go path. Oh, wait, no. Import path test admission is not supported. Why not? Make dir github.com jbeta move tgik.io test admission github. Make dir dash p github.com jbeta move okay. Failed to publish. Go cannot find main module. Oh, see. What is the import path? Oh, I see. Okay, so sorry. Code. Now if I go mod, this should be github.com jbeta. I don't understand what's going on here. Go path, echo, go path. That's right. So I can build stuff. Why is co not working for me? Source examples. Check go.mod. I did. So go.mod is github.com jbeta test admission, github.com jbeta test admission. I'm in the go path. Right. So that should all be good. Go source. Oh, your workspace is. So I don't freaking know. Yeah. Go env. Modules are on. Go path is right. Runs off to find someone. Be right back. Yeah, if you can get Matt, that'd be good. Usage. Okay, so we do the Docker repo. Blah blah. Okay, so I'm gonna co-publish dot failed to publish images. What is going on here? Is supported reference. Doesn't tell me why it's not a supported reference. This is actually really lame. Publish images. Okay, is local import, qualify local import, is supported reference, so build interface. Oh, here's example. So github.com/foo/bar. I am feeling stupid here. I'm feeling like I don't got this. What is going on here? github.com jbeta. It's not going to change anything. Okay, so import path is not supported. Failed to publish images. I know. So let's do publish-l. Are there the old module path in the other files? I don't think so. If I do tgik.io, yeah, nothing found there. And it's trying to do the right thing here. But like now it's like preserve import paths. Yeah, I think that's like how it names the. Yeah, uppercase L. God damn it. Okay, Matt, I'm going to be mad at you. Okay, let me like go get this. We'll get the updated version of this. Go get. And my terminal's giving me problems now too. Okay. So here we have a deployment. Suppose go path is this. The current directory is examples. Resultant images. Using for that. So it's telling me all that. Be referenced by blah, blah, blah. Yeah. Okay. Let's see. Let's do go path bin co. Oh, now it's actually giving me crap. Oh man, I'm getting a conflict with go mods. If I had hair, I'd be pulling it out right now. This is flailing here. All right. We're gonna abandon co because I'm not gonna get that working. We're going to do a Golang Dockerfile example. I'll copy and paste that. Let's see, that's old. Let's pull a new one here. Does somebody have a good example? Okay. Yeah, I'm just going to build the Docker image. So we're going to do that. Dockerfile, Golang 1.14, source, Joe Beda, test admission. Is that what it's called? Yeah. Copy, and then I do let's do a go install. Expose 443. This thing will be a little bit chunky, but that's okay. I did an episode on Co, and now I can't get the damn thing to work. All right, so now we're pulling down the Golang. Yeah, what's a site that builds Docker images from GitHub repos? Yeah, I could do that. I'd have to create the repo, though, because I haven't done that yet. I was going to do that after the episode and upload it for y'all. All right, so this should work. Now we're actually doing the work dir. We're copying everything over. Go run install. It's going to download a bunch of stuff. This is going to be super slow, but that's okay. Yeah, cloud native build packs would be sweet here, too. This is one of those things where it's like, you know, you always have something set up and like it just works. Okay, so now we're actually got this. Okay, and so now we can do Docker build -tag test admission v1. We're going to do that. So that we have a tag for this thing. Docker images, right? And then we have kind, and we do kind load, and then we'll do test admission v1. Oh, Docker image. All right, so this will load this into kind. This takes a little bit. All right, so now, yeah, so I wasted so much time with co, I could have just done this. Oh, did we break again? Did we lose it? All right. What is this thing doing? It's working hard. Okay, still here. Cool. All right. So this thing's okay. So we're gonna get this running, and then we're just gonna do a we're gonna do two things. Is that we're gonna actually get a deployment running with this thing. It's gonna error out, and then we need to actually create a TLS. Let's see. As we look at the dynamic. So we have to actually do TLS, and we have to create a certificate and admission controller TLS. Now, one of the things that folks have actually been doing, which is really interesting, is that they've been reusing some of the CA stuff that's been built into Kubernetes for actually doing server certificates for this. So here we have a shell script and an example here. Oh, look at this. We have StackRox has a demo one. But generate keys. All right, let's actually copy and paste this here. Touch gen keys. And then we're going to go through and look at gen keys.shell. We're going to paste this. There's a bunch of stuff here. But key directory... chmod the key directory, and then we're going to actually go through and create a CA here, generate a private key, and then go through and generate a certificate signing request for the private key and then sign it. Okay, so this is using OpenSSL. There's the CFSSL, which is another toolkit that you can use. Do I have OpenSSL? Yes, I do. So now I can do a chmod plus x gen keys. So this is just self-signed. Keys. Make dir keys. All right. So yeah, now we have a private key. So here we have keys. Where we have both the, let's see, the things that we're going to want is if we look at our config here, what we're going to need is we need our cert file and our key file. And so the cert file is going to be this thing here. And this is the key file. And then here's our CA certificate, a self-signed certificate that we're going to use when we actually configure the thing. So does that make sense? This is all voodoo. This is actually, I think, a real rough spot in the Kubernetes ecosystem right now, is that generating these certificates, configuring them, super error prone, super pain in the butt. Rotating them is not as easy as it needs to be. This is something that I think as a community, we need to go ahead and get better at. All right, so what we're going to do is we're going to put the keys in a secret. And so make dir deploy, cd deploy, touch deploy.yaml. We're going to look at deploy.yaml. We're going to have a deployment YAML. Right, so I'm just going to like copy and paste because we're not doing anything too fancy here. Deployment, this is going to be test admission. We're going to put this, we're going to do one of these things because why not? Ports 443. Is that right? Spec, containers, ports, yes. And then config map example Kubernetes. I'm so bad about this. I should have this stuff all memorized, but you know, me and the rest of you. Okay. Okay. Kube control create config map dash o YAML dash n. No, it's not n. It's dry run. Dry run, is it? Oh, is it dry dash run, dry underscore run? Okay, and then we need the name equals TLS. Let's see, TLS keys and yeah, okay, I need the config map name is going to be TLS keys, and then we need to do from file. Okay. Okay. From file. So we need the webhook server tls.crt from file webhook key. Oh, and I want this to be, oh, what is going on here? Shoot, kube control create secret, not a config map. Oh, this thing is kube control create secret. Oh man, kube control create secret dash o YAML dash dry run, and then we want to say TLS config. That works. Oh, what am I doing wrong? Yeah, I did reset, and it's like not. Okay, kube control create secret. Help. Okay. We can do a generic secret, or let's do a no, generic or TLS. We can do that. And then we have to give it, okay, certain, okay, yeah, gotcha. Okay, so, and then we're going to pass in here, we have to give it a name, TLS, key equals, key, cert, equals. Yeah, if my terminal weren't all messed up, this would be a lot easier. Okay, so that we got that. Okay, so that actually created it in the cluster. Kube control get secrets. All right, good enough. Yeah, it could be. Yeah, export PS1 equals. Let's do this. Okay, that's a lot easier. Mood. STTY sane, does that work? Well, we're already here. Okay. All right, so now we have that thing. Now we want to reference the secret from our application, right? From our deployment. So now what we're going to go through is, this is secret Kubernetes secret example. Creating your own secret. So we did all that, blah, blah, blah. Create secret generic. manually. We have that generating secrets. Where does it have editing a secret? Consuming secrets from volumes. Okay, so this is what we want to do. Oh, immutable secrets is new. That's fun. Okay, so volumes. All right, there we go. Okay, so now what we're going to actually go through is in spec. Volumes. Name TLS. You know, and this is the thing where it's like, you know, doing this stuff from the ground up, you know, creates a whole bunch of, you know, stuff that you have to actually sort of figure out. I called it TLS, right? So, okay, so now we have that volume, so that's all we need. And then when we actually mount it, we need a volume mount. And the syntax here is name TLS. Read only true. Mount path. And we'll just go TLS like that. Okay. So now what this is going to cause is it's going to take stuff from the secret, it's going to put it on the file system, and then it's going to make it available mounted in /TLS inside of the container. And now we need to actually reference those things. So we actually have a parameter here, which is TLS cert file and TLS private key file. Okay. And so we're going to do, and so now I have to remember sort of image, args, what's the syntax? I always forget this too. Kubernetes, args pod. Okay. So that's just a, so now we can make this be a list, and we want to do TLS cert file equals, and I'll put the TLS slash, and oh, I don't know what it's actually called there. So let's do kube control get secrets TLS YAML. This thing is called TLS.crt and TLS.key. Okay. TLS.crt. Was key file. Oh, private key. Equals TLS.key. All right. Do you all think this will work? Let's see. Cube control apply dash F. Okay, so get pods. Do I have, okay. Get nodes. I actually have it. Okay. Cube control apply dash F deploy.yaml. Cube control get pods. Crash loop back off. That's what we want. Gonna take a miracle. Exactly. Okay. So cube control logs. Let's see what we did wrong here. I have to give it the previous run. Oh, what did it actually? Logs dash P. Cube control. Cube control get pods. Cube control run container error. Cube control describe. I don't know what run container is. Okay, so Failed to create container D task, OCN times, starting container cause exec. Oh, I forgot to actually, the arg here, that has to be, oh, that I don't have command. Oh, did I have a bug? Let's do that. I think I need the command, right? Okay, so where's my deploy.yaml? I think the file is missing. It says starting container process caused exec, no such file, directory unknown. Okay. Wait, what is validating? Okay, now it's running. Sweet. All right, so that is up and running. So now, okay, woohoo, we actually got the damn thing running. I think if you specify args or command in the pod spec, it will automatically use that instead of, yeah. So I think it doesn't combine those things with the Docker image. Okay. But that is sort of like, so this is like the hard part of installing an, you know, an admission controller is actually getting this stuff up and running. So now what we should be able to do is we should be able to do a kube control port forward to this thing 8443 to 443. Let's actually do that. So now we're actually port forwarding to this thing. And now I can do curl localhost 8443. And that's going to give me, okay, that's going to give me an error for curl. What is the, say, ignore TLS errors, insecure. Curl -K, is it -K? Should be -YOLO. Page not found, okay. And then let's see, what do we have? What other routes do we have here? We have readyz. Okay, all right. So we got the thing up and running. We can connect to it with TLS with a self-signed cert. That took us way too freaking long, but there we go. Now, what we need to do is we need to actually, let's see, we need to actually set up a service for this thing. So we're going to actually go through and do, all right. And so we, let's see, what was the name of the service that we had with Gen keys? Oh, oh, shoot. The common name, test admission. I forgot to change that. Damn it. And default dot service. Okay. So we're going to actually do that. We're going to regen the keys and rm keys star gen keys cube control create cube control delete secret TLS. We're going to create that again. Let's see. So this thing is going to now be called cd deploy. All right, now we've created that. Cube control get deploy. Cube control delete tested. And we're gonna now do the apply again. Okay. All right, so now we actually have, Okay, so now let's see, if we go to deploy here, we need a service for this, because this is what the API server is going to use to talk to the darn thing. Good enough. Test admission app test admission, and we're going to do 434443. The TLS certs were for the wrong entity. Yeah, that's why I did it. Is that I forgot to actually change the common name in the certificate, and so that was likely to actually cause us problems in the future. Kube control get services, kube control apply. All right, kube control port forward service test admission 8433443. And now if I do curl, boom. Okay, so we got that up and running again. Okay, we'll control C that. All right, so now we're finally ready to actually install the admission controller. And so the next thing that we're going to do is, so now we have to actually sort of tell the API server that it should call out for this thing. Let's see, docs on dynamic configuration, webhook configuration. And so let's do a validating admission controller. This, is there other ... stuff that matters? Does that matter? All right, well, let's see what happens here. Touch register.yaml. Okay. So now we're going to do a creator update of API versions of, let's do config maps. Config map. So these things, I always forget these are v1. We'll just do the API version v1. Okay. Yeah, we'll need to reference the service and include it. Yeah. And so one of the things here is that I see these are lowercase, so I'm assuming that they're lowercase here too. Scope, namespace, create, update, API groups. Okay, so we have that. Now we have to figure out there we go. Okay, so now what we have here is name, webhook, blah, blah, blah. Client config. This is the thing that we actually have to configure now. And that thing is like this. Okay. So the service that we're actually talking to, the namespace is default. And then test admission. And then the CA bundle is a PEM encoded CA bundle, which will be used to validate the certificates. Okay, and so keys. Config maps. Okay. Cat. Okay, so now this thing is this thing. Is it base 64 encoded? Is it base 64 encoded? I assume, okay. Base 64 encoded PEM bundle. Okay, so now we do base 64 key CA dot. Okay. PB copy. So that's now on my paste buffer. And then I can actually do CA bundle like that. All right. Should be the root CA used to generate the client. That's what I did. Yeah. So this thing is, that's why I did the ca.crt, which is different from, I mean, either would work actually, I think, but I think this is what we're actually doing here. Okay. So now kube control. Okay. So let's see. So now we have the register here and we're saying we're doing config maps for create or update. Can you do, what are the events? Can you also do get? I don't think it actually works for get. I think it actually skips past it. And so this gives you a ton of data on sort of like how you actually specify these things. Create, update, delete, connect, or start a match all. Okay, so we'll do that. Yeah, no, it doesn't support get. Yeah, that's why that's one of the big differences between this and audit. Okay, cube control apply -f register. Oh. Error validating, missing required field side effects. Okay, so side effects. Side effects none. So that is appear to this. Okay, and then what other stuff do we probably want here? We can have a timeout. Let's make a timeout be 1 second. And then how do we actually fail open? Because I don't want to fork my cluster. None on drive. Okay. Oh yeah, cube control. I always forget that. Cube control explain valid. Webhooks. Oh, validating web. It didn't like that. Failure policy. Cube control API resources. Validating webhook configurations. There we go. Yeah. Failure policy ignore. Okay, so that way, if this thing doesn't work, we're not going to fork our cluster. And there's like a recursive thing that I can do. Yeah, so here's the, okay, yeah. So we have the CA bundle, service, name, namespace, path, port. Oh, we can do path here. The path that we want on the webhook is, that's under client config service. In main, what do we got? We got, we'll do config maps is the one that we have here. What do you think is this? Config maps. We'll do that. Okay. Rule, side effects, timeout, sweet. Okay. I think we're good. Let's apply this puppy. Cube. Okay. Required missing field admission review versions. Oh, what is this? This is the we're gonna YOLO it and just do V1. Hell, we'll do both. Error when retrieving current configuration resource. Name. Oh, I forgot to do the. It's a payload version to. Yeah, okay. So we have to do meta. Fail, ignore has to be capitals. Yes. Okay. Sweet. All right, so, haha. Now touch test config map.yaml. I'm going to do octant. We're going to bring octant up. All right, and so what we're going to have here is cluster overview. I think we're okay. Okay, so we're going to be looking. This is a little hard to read. Sorry. We're going to be looking at this pod here. We're going to be looking at logs, and we're going to be seeing what's going on here. So, so we should be okay. So now we need to have a test config map. Yeah. So we're going to take test config map, and I need to do a example config map that I can start with, because again, metadata name test config map, and then this is data foo bar. Okay. So we should be able to do cube control apply -f test config map.yaml. It created it, and let's see, do we have any logs? Does this thing actually log it? Okay, so that, what do we got going on here? So we have the config map is in serve config maps. That thing is in admit config maps. Oh, the namespace selector, yeah, to footgun. But I think if you don't specify that, does it do everything? All right, so this thing, okay, so, okay. So this thing is actually going through and doing the review here. I thought it would log everything. Lame. Okay, let's have this actually log everything. Admission reviewed our resource. Okay, so AR dot. How do I actually get this to something that I can actually? Okay, well we're gonna have to modify our shoot. Main.go. So this new delegate, what is that? Where is that thing defined? Admit handler. Okay. Delegate to v1. So this does a bunch of, and then it returns a function in, out. Okay, and then we're going to be going through and we're going to be doing a klog dot info ln review dot request. Think that'll work? What do y'all think? And so this will actually, hopefully, if we do this right, this will dump stuff to the log, right? Oh, this one. Oh, this is the delegate v1 beta 1. Oh yeah, shoot. So return admit handler. OF. Admit function do delegate to admit handler. Oh, serve is where I want this. Okay, so this is going to read all, put that in there, verify the content type, handling request. Okay, so we'll do, okay, yeah, okay, sweet. So it is actually logging stuff. We're just not doing the verbosity thing, if you're not into the whole brevity thing. So now we can do b equals 2, do that, do cube control apply -F to this, so that'll actually roll it. We're going to get a new pod here. It's thinking hard. Why is it restarting? Drop v1 from the YAML. Back off, restarting container failed. What did I do wrong? Oh, God damn it. I forgot to add the log, klog init flags, logging flags, log set, parse. All right, if we're going to do that, let's just change this thing to info, and it'll actually log all the time, right? Is that going to work? And Octan's throwing errors on me here. So we'll do that. Okay. Docker build. Kill Octan. We're going to build v2. Oh. Oh, and this is going to have to like pull down the world again. At least we're not pulling down Kubernetes. That'd be bad. Okay, now we'll load v2 over. Hopefully it won't have to do the whole thing. But now we're going to actually go through and update our deploy.yaml to actually push v2. This is why I want co with some yeah, I want co with some you know, integration with kind. But kind load is really freaking slow. My guess is it actually is grabbing the whole thing. If I had actually gone through and done a multi-stage build, it would be a lot smaller. We have a Matt now. Matt, I wasn't able to get co working. I'm going to have to, like, we're going to talk about this later. We're going to have words. Push to Docker Hub, yeah. No, it wasn't Docker Hub. I was trying to push to, like, my local one. Okay, so, but I should be a multi-stage go build Docker. Slack close, likely story. All right. All right. Well, we got it. Okay. Next time we'll do that because that took forever. CD deploy, apply, boom. Okay. Octant. Is this thing now pissed at me again? Oh, I forgot to take the V off. Shoot. Usually I run Octant in a separate terminal window to help out here. Okay. All right, now this thing's running. We have logs. And now, let's see. Cube control, delete, -F, test config map. Yes! All right. So this is what we were working to get to, but this is actually really cool. And so one of the things I kind of want to do is I want to build admission control dumping into Kubernetes up and running daemon, sort of my little test thing. But what you see here coming in is that it just does a post to you of an admission review. And so this is actually ends up being just sort of JSON here. So like what we're going to do is I'm going to copy this and do PB paste to YQ, JQ. And we can take a look at this. And you can see what's actually coming in here. And so the request coming in is we can see that, oh, it's for a v1 config map. And then we have, and there's resource and kind. So there's a whole bunch of different, like the request resource and the request kind, and it sort of moves, you know, is able to sort of convert between different schemas. We see that we get a create here in the default namespace. And then there's information about who's actually doing it. So this is really interesting. And this is where admission controllers and the audit log actually starts to overlap, because you do get other information about the request coming through, including who it is that is actually calling, which is interesting. And then you get information about sort of like, here's the data. And so here's the raw data that is actually getting posted, including a bunch of stuff like managed fields and stuff like that. And then other metadata about this. So if you're doing a change, there's the old object. Here it's null, meaning that there was no previous old object. Yeah, so Docker, so kind load pretty much does a Docker save exec, and so it's big. That's because I actually did a full image, a full Golang image. I didn't actually create a minimal image. And then other options in whether it's a dry run or not. So there's a lot of really good information here. But I think one of the fascinating things here is that this is a way to essentially plug in to the request flow and actually see stuff. It's also dumb about loading the whole thing instead of layers. Yeah, so it should actually be layer aware. So now one of the things that is in this test image that we built here, if we look at config map, is that it's actually looking at if we actually set a value of webhook E2E test and we set webhook disallow. So now if I do this and if I set to this, now what'll happen is if you look at the code here, it'll actually go through and say review response allowed, and then you have a result, and you can specify any sort of text that you want here. And so now if we actually try and do this, what we actually get here is that we get an error from the server, and it says the config map contains the unwanted key and value, error when applying. So it actually dumps a bunch of JSON there, but it actually gives you information about sort of which resource and what you're trying to do and which webhook it was that actually denied the request. mywebhook.example.com denied the request. The config map contains unwanted key and value. So that's actually like, that is really what we actually have going on here, which is really fascinating. And then we can actually go through and we can make the thing non-deletable. So if we go through and let's now change our test config map to be non-deletable. So now we can actually go through and update it. But now if we actually go through and try and do a delete. Oh, wait, it deleted it. Why did it delete it? Is that because I'm an admin? Is that, so let me look at the code again. That is interesting. So why did it let me delete it? I think it's probably, what is going on here? So let's look at the code again. Did I apply? Yeah, so, okay, so here's what we got. We have webhook E2E test, webhook non-deletable, okay? And we're gonna look at the code here. Webhook E2E test, webhook non-deletable, and it's a delete request. Then allowed should be false, and it should actually tell us that we're not allowed to do it. and then it returns the response. Did you add delete? No, I don't think I did. Let's actually look at my register here. Ah, so we didn't actually get called for it. Okay, so now if I do delete, and now if I do cube control apply -f register, right? Now if I actually try and delete it, it's going to tell me no, I'm not allowed to delete it. And then Matt's saying that if I actually do validate equals false, where do I actually pass that in? Is that unknown flag? Wait, no, it didn't delete. Unchanged. Okay, so it didn't delete. Cube. Is it validate? Recursive output, customize, dry run, cascade, all namespaces. Is this a... Need to apply. So yeah, we did actually apply it. So it's applied. Oh, cube control the config map. Okay. All right, so now we're trying to delete it. We're getting the error. And now if I do... Oh, is that on apply only? Maybe only apply has it, huh? All right, so now this is one of the dangerous things about admission controllers, is that now I have something that I actually can't delete, and even though I'm root on the thing, it actually doesn't want me to actually do it. And so this ends up being like, it's really easy to sort of foot gun yourself on this thing when you have admission controllers that are actually happening behind the scenes. And so that's why the let's see, and I think cube control apply -f. Is there a dash force? Do we have a force? I don't know if we do. So we have all, oh, force. Let's try force. Yeah, so still denying me here. So yeah, okay. So yeah, so that gives you an example here. Now we set this thing. So Duffy's suggesting that we scale to 0. So we're gonna go cube control delete -f. We're gonna actually delete the service. Octan's pissed at us now because we no longer have that thing going. And so now if we actually try and do the delete, it'll actually delete it. Because what we see here is that we had the failure policy here to actually fail open here. But now what we're going to actually go through is if I go through and change that failure policy on my register to, what are the options for failure policy? Fail. Okay. So now we're going to fail closed. Okay. And so we're going to apply that. Okay, so now we're going to try and apply this thing. And the apply is going to actually time out because it's like, I can't find that service. I actually don't know where it is. And so now we're actually, failing here. If we actually bring our thing back up, cube control apply -f deploy. So now we brought the thing back up, and now we can actually go through and create the config map because it's running, right? But we still can't delete the thing because it's, oh, wrong thing. I deleted the wrong thing. But if we try and delete the config map, it's still going to give us a problem. So yeah, so now I guess there is the question. I think maybe this is actually a bug with let's see, bypass ed. Let's actually see. Oh, there's no bypass. Yeah, so I think the best way to bypass it is to actually go through and deregister it. And so cube control delete -f register. Now it's actually deleted, and so that policy is no longer applying. So I can now go through and do the test config map. You can actually see how that goes. So there we go. And so that's the basics of how things are going. Now, similarly, what you can find is that if you look at this code, if we're going to look at config map, there's a mutating one also. So this is admit, mutate config maps. And what this thing will do is config map patch. Okay, so it's actually doing a... Okay, and so this is a JSON patch that essentially, so instead of actually returning the entire resource, because that could be expensive, this thing is actually saying, well, I just want to actually add this particular mutation stage there. And I think we're running out of time, so I'm not going to do that. But I think hopefully this is enough for you all to get started, that if you want to play around with writing this stuff yourself, we went through, and I'll check in this code, how to build the Go binary, how to package it up, how to push it with kind, how to set up the TLS, and then how to get this stuff up and running so that you can start playing with it. And this really is all that there is to admission controllers. But the fascinating thing is that once you have this window into this world, you can do so many interesting things, whether that be stuff like OPA, or really it's like one of these things where you get sort of this, you know, main line into the request stuff. You can start playing around with it. You can start learning. So many cool things happen with this. So it was a little bit rough there. You know, we had some stumbles, but I think we got there in the end. And I really appreciate you all joining and staying with me through this. Hopefully we all learned something. And I will see you all next week. I think I'm going to be either me or Duffy will be next week. And I'm not sure what we're going to be talking about yet, but send me suggestions on Twitter and we can dig into it. In the meantime, have a great weekend. If you haven't started your weekend already, and stay healthy, stay safe. Let's all deal with being at home and do our best. And I will see you all next time. Bye.